Section 0. Welcome to the R3S Modeler Advanced Training Module, External Assumptions, Placeholders and Batches. In this course, we will show you how to read in external assumption files and how to use placeholders and batches. There are 3 sections in the course. Section 1, External Assumptions. Section 2, Runtime Parameter Set. Section 3, Batches and Model String. The objectives are as follows: amending assumption sets to read assumptions from an external Excel file. Introduce the runtime parameter set component and use runtime parameter set variables to amend model parameters at runtime. Introduce the batch component and the system variable model string. Set up a batch model to run the same model sequentially using different assumption files for each run. Set up a batch model to run the same model sequentially using different stress names akin to our Solvency II standard code models. This course is delivered through a series of instructional videos designed to guide you step by step while allowing you to learn at your own pace. Section 1.0. In this section, our objective will be to amend the assumption set to read assumptions from an external Excel file instead of using internal assumptions. The aim is to amend the assumption set, realistic assumptions, to read the variables, int rate and surrender rates, from an external Excel file. In the Life Foundation course, these were defined internally. In Modeler, each assumption within an assumption set can be set up in one of 2 ways. Internally, the assumption value is either specified directly within the assumption set or derived from its formula. Defined externally with a link specified to an external source outside of Modeler containing the value of the assumption. We will set the assumption connection string to link to the external assumption file in the General tab. Then, in the Variable tab, we will specify the corresponding name of the table, in the database in the Assumption Table property, and specify an external assumption expression to tell Modeler how to read the table. Note that the assumption connection string here is for setup only. To link the assumption file to the model, we need to set the assumption connection string in the model. For this section, the workspace we will be working on is Stage 1. ext_as_ph batch start point. There is an external assumption file, ext_assumptions_base, which we will use. These files are saved in the Stage Workspaces folder. Section 1.1. To begin, open the Stage 1 workspace. Go to File. Click Open. In the Stage Workspaces folder, click on Stage 1 ext_as_ph batch start point and press Open. Let's look at the current assumption set settings. Go to the Workspace Explorer. Open the Realistic Assumptions assumption set. Go to the Variables tab. Observe that the variable int rate is defined as a scalar value, whereas the variable surrender rates is an array with different rates depending on the product and the duration in force, which is a 2-dimensional array. To see the layout of the table in surrender rates, select the Formula property. Right-click in the Formula pane and select Specify Array Constant from the menu. These 2 variables will be referenced from an external assumption file. Let's look at the external assumption file. In the Stage Workspaces folder, in the Assumptions folder, open ext_assumptions_base. This file contains the same values and table layout as the corresponding assumption set variables defined in the assumption set realistic assumptions. The assumption tables in the Excel file are referenced by range names, so Modeler can locate them into the external file. This is different to the database table name property in the data process, where we reference the Excel tab name using the $sign. Close the file. We are going to create a new assumption set to pick up assumptions externally. Right-click on the Assumption Set folder and select Add Assumption Set. Name as realistic_assumptions_ext. Drag in realistic assumptions as a sub-assumption set. We will override the variable int rate and surrender rates. To do this, simply copy the variable int rate and paste it in the blank area. And delete the formula. Now you will see this variable belongs to the realistic assumptions ext assumption set. If we look at realistic assumptions, the formula won't be affected. The next variable is surrender rates. Again, copy and paste to a new line and delete the formula. Next, we will define the assumptions connection string property of realistic assumptions ext to use the file ext assumptions base. A database connection string is a Unicode text string that enables Modeler to access a database using Microsoft OLEDB. To set this, go to the General tab. Right-click in the Assumptions Connection String property and select the Locate OLEDB Connection String option in the context menu. This will open the Data Link Properties dialog box. Select Microsoft OLEDB Provider for ODBC drivers and click Next. Select Use Connection String and press the Build button to open the Select Data Source dialog box. On the Machine Data Source tab of the dialog box, select the required data source name, DSN, from the list. In this case, use Excel files to connect to a Microsoft Excel workbook and press the OK button. Use the Select Workbook dialog box to select the ext assumptions base file and press the OK button. Use the Test Connection button to verify that the database is accessible. Press the OK button to return to Modeler. The Assumptions Connection String property should now contain a database connection string similar to the following. Next, go to the Variables tab. Now we have completed the Assumptions Connection String property, we can then complete the Assumption Table property of the assumption set variables, int rate and surrender rates, by selecting from a list of range names available in the Excel file. First is int rate. Click on the Assumption Table and right-click in the Formula pane. Choose the Locate Table option from the context menu. Select the table int rate. Note that the variable name in Modeler can be different to the range name in the Excel file, but the assumption table name needs to be the same as the range name in the Excel file. Next is surrender rates. Click on the Assumption Table and right-click in the Formula pane. Choose the Locate Table option. Select the table Surrender Rates. Note that we can locate the table here because we have set up the assumption connection string in Realistic Assumptions ext. If you try to locate tables for other variables which belong to another assumption set, for example, the variable mortality rates, it will show a message. Unable to locate table as connection string is not specified. This is because the variable mortality rates belongs to the realistic assumptions assumption set, and we didn't specify the assumption connection string for that assumption set. Next, we will specify an external assumption expression to tell modeler how to read the table. For int rate, go to the formula property and right-click in the formula pane. Select Specify External Assumptions. The interest rate in here is a scalar, so tick the scalar checkbox and press Check. It will show the value 0.05. Click OK twice and the string external will appear in the formula property. For the assumption set variable surrender rates, go to the formula property and right-click in the formula pane. Select Specify External Assumptions. In this case, it's a two-dimensional table. The first dimension name is product. The data type is character. The second dimension is duration in force. And the data type is numeric. Press the check button and then click on Configure Dimensions. The size parameter for each dimension name has been automatically populated by Modeler. If you expand a dimension name, you can also see its index and position settings. Click OK 3 times, and the formula property for the variable surrender rates will be set to the following. In Modeler, table arrays are read from right to left. Here is an example. For a two-dimensional array, the first index is product type, and the second index is expense type. Similarly, for a three-dimensional array, the first index is product type. The second index is expense type, and the third index is basis. In our case, the first index is product, and the second index is duration in force. An array in an external workbook can have up to a maximum of 5 dimensions. Note that the assumption connection string in the assumption set is used to help define the above-mentioned properties, and it is not used at runtime, so it can be removed once all the assumption set variables have been defined. Now we are going to take a copy of the company model to use external assumptions. Click the company model. Under Component, select Duplicate and name as company_ext. Open it. Double-click the realistic layer. We will change the assumption set from Realistic Assumptions to Realistic Assumptions ext. To tell the model which external assumption file we are referring to, we need to set the assumption connection string in the model. For the realistic layer, click on the layer and find the assumption connection string property. Similar to what we did previously when setting up the assumption set, right-click, select the Locate OLEDB connection string option in the context menu. Select Microsoft OLEDB Provider for ODBC drivers and click Next. Select Use Connection String and press the Build button to open the Select Data Source dialog box. Go to Machine Data Source select Excel files, and press OK. Select the Ext Assumptions base file and press OK. Use the Test Connection button to verify the database is accessible. Press the OK button to return to Modeler. Now we have completed the model setting to link the external assumption file with the new assumption set. Save the workspace. Now we are ready to run the model. Name as company_ext and run using Sample All mode. Press OK. Once the model has finished running, go to the Analyzer tab. Click Confirm Layer Selection. Select the NP-end program and select the variable int rate. You will see the formula defined as follows, which is referencing the external assumption file, and the rate is 0.05. Note that the external assumptions connection string property can be set in any of the following components: model, data process in a model, data source in a data process, layer in a model, and program in a layer. Also, as a variable can be defined simultaneously in two or more components, Modeler applies orders of precedence to resolve any references to variables that are defined in multiple areas of a model. There is an order of precedence table from the Help tab. This table includes an initial order to calculate the initial information portfolio and a second order thereafter to calculate the closing information portfolio in the projection steps. These orderings are indicated in the table separately for non-targeting and non-stochastic layers respectively. This is the end of section 1. Section 2.0. In this section, the objective is to introduce runtime parameter sets and demonstrate how runtime parameter set variables can be used to dynamically adjust model parameters during execution. Runtime parameter sets are used for defining which data-independent variables will be specified or calculated at runtime. For example, a developer of a model could parameterize the portfolio date of the model using a runtime parameter set variable in the portfolio date property, and the location of files containing external assumptions using a runtime parameter set variable as a placeholder variable in the file path, so that a user can change both parameters each time a model is run without needing to modify the model. For this section, the workspace we will be working on is Stage 2, Ext As completed, and the external assumption files we'll be using are Ext Assumptions Base and Ext Assumptions Sur Inc. 40p. These files are saved in the Stage Workspaces folder. Section 2.1. To begin, open the Stage 2 workspace. Go to File, click Open. Under the Stage Workspaces folder, click on Stage 2 Ext As completed and press Open. We will create a runtime parameter set called Runtime Parameters. and create some runtime parameter set variables for the assumption location, the name of the assumption file, and the reporting date. Go to the Workspace Explorer. Right-click on the Runtime Parameter Sets folder and select Add Runtime Parameter Set. Name as runtime_parameters. Go to the Variables tab. The first runtime parameter set variable we'll define is assumptions_location. The data type is character. The display name is file location of assumption spreadsheet. The display instruction is enter full file path and set the default value to the following. We will use the system placeholder variable workspace folder to locate the path of the workspace. The next variable is assumptions_file_name. The data type is character. The display name is name of the external assumption file. The display instruction is enter file name, and the default value is set to the assumption file ext assumptions base. This can be copied from the name of the file. The next variable is reporting_date. The data type is date. The display name is model portfolio date. The display instruction is enter portfolio date, and the default value is set to 31st of December 2017. This completes the setup for the runtime parameter set. Save the workspace. Now we can attach the runtime parameter set to the model Company ext. Open the Company ext model. Select Runtime Parameters for the runtime parameter set. In addition, we need to amend the model so that some of the properties will reference the variable from the runtime parameter set. For the portfolio date, in the model property, change the value to reporting date. Click on the realistic layer and go to the properties. For the assumption set connection string, use the placeholders assumptions location and assumptions file name in the connection string instead of the original directory and file name. As shown here, the area highlighted in blue is the assumption location, and the area highlighted in green is the assumption file name. Note that the default dir argument in the connection string can be removed as it is not used by Modeler. This is a Microsoft default. Also to note, there's no need to add the backslash as it is included in the runtime parameter variable default value. Let's go back to the model and replace them. After replacing the assumption connection string, a warning message stating that a connection to the database cannot be established may appear. This occurs because these variables will have a value during compilation time only, but not when applying the changes. We have shown that we can use a character runtime parameter set variable in a non-formula property, such as in a database connection string property like above. Then you should use it as a placeholder variable by enclosing its name within angle brackets. A runtime parameter set variable can also be used in the formula property. To reference it, just set it by name like any other variables. Now we have completed the link between the runtime parameter variables and the model. Save the workspace. Run the model. Set the name to company_ext. Run in sample all mode. Press OK. This is the results workspace. Let's try to run the model again with another assumption file, but skipping the compiling stage of the run. We can click Run directly in this results workspace. Set the name to company_laps_up. You will see you cannot change the run type. Click Runtime Parameter Set Variables and amend the value of the variable assumptions file name to ext assumptions sir inc 40p. This can be copied from the name of the file in the assumption folder. Press OK. When running the model using the results workspace, we can skip the compilation stage of the run. Using a runtime parameter set, we can run the same model with different assumption files without having to amend the assumption connection string inside the model. Let's look at the results together. So, for company ext, in the runtime parameter set variable, it is referring to the ext assumptions base assumption file. Go to the Analyzer tab. Click Confirm Layer Selection. Select the np-end program. Select the variable surrender rates. The rate for the EA product at duration 0 is 0.2. Now go to the results workspace, Company Laps Up. In the runtime parameter set variable, it is referring to the ext assumptions sir inc 40p assumption file. Go to the Analyzer tab. Click Confirm Layer Selection. Select np-end. Select the variable surrender rates. The rate for the EA product at duration 0 is now 0.28. Section 3.0. In this section, the objectives are as follows. Introduce the batch component and the system variable model string. Set up a batch model to run the same model using different assumption files. Set up a batch model to run the same model under different stress scenarios, similar to our Solvency II standard code models. Batches are used for running several models sequentially. The same model can be included more than once within a single batch, using a different model alias for each run. Combined with the facility to read assumptions from external sources explained in the first section of the module, this means that a single underlying model can be combined with several different external files within a single batch. This reduces the need to set up multiple models in situations where the only difference between them would be in the choice of assumptions. For example, for sensitivity runs. You can have different models within the batch, and it is also possible to set priorities for running the different model aliases, which are most used when a model needs to access the results of another model. Next is model string. It is a system variable and a character variable. You can specify its value for a model in the model string property. You can specify its value for a model alias in a batch in the model string override property of the model alias. If that property is blank, then model string takes its value from the model string property of the model. Hence, model string takes its value from the model property in the model alias of a batch with a non-blank model string override property. You can use the placeholder model string to refer to this variable in some properties. Note that there are up to 5 different model string system variables available in Modeler. For this section, the workspace we will be working on is Stage 3, RTP completed, and the external assumption files we'll use are ext assumptions base, ext assumptions Sir Inc 40p, and ext assumptions int rate stresses. These files are stored in the Stage Workspaces folder. Section 3.1. To begin, open the Stage 3 workspace. Go to File. Click Open. Under the Stage Workspaces folder, click on Stage 3 RTP completed and press Open. Recall that in Section 2, we ran the model separately with different assumption files. Now, instead of running them one by one, we are going to set up a batch process to run the same model with different assumption files. To do that, go to the Workspace Explorer. Right-click on the Batches folder and add a batch. Name as batch_sensitivity. The first model alias is company_base. And the second one is company_Sir_Inc. For the model property, company ext is used for both model aliases. Note that when selecting the model properties are already shown in the model aliases grid, i.e. portfolio date. Next, add the runtime parameter set runtime parameters to the batch. When a batch is run, any runtime parameter set attached to a model is ignored, and only the one attached to the batch is used. Consequently, the runtime parameter set attached to the batch must contain all the runtime parameter set variables required by all the models in the batch. Next, we need to check if the necessary properties are shown in the central pane. We will need the model string property and the model string 2 property. In the example shown, the model string 2 property is not shown. To view this property, right-click on any column. Select Field Chooser and drag in Model String 2. We will also need Model String Override and Model String 2 Override. These are the properties we will need for this section. Right-click a column and select Save Settings. Before finalizing the batch setup, we will amend the model properties by setting the model string as a variable to hold the assumption file name. This allows us to override the model string for each model alias within the batch. Specifically, we will set up the model string property inside the company ext model, so when the batch runs, the model string override will apply the different assumption files. Open the company ext model. Go to the model properties. Set the model string property to the following. Go to the Layer tab. Select Realistic Layer. Find the Assumption Connection String property. Replace the assumptions file name placeholder with model string. Go back to the batch sensitivity. We can see the model string property is already populated. Now we will complete the model string override property to use different assumption files for each model alias. For the company base model alias, it is the ext assumptions base file. We can copy the name from the assumptions folder. For the company Sir Inc. model alias, it is ext assumptions Sir Inc. 40p. Again, copy the name from the assumption folder. This completes the batch setup. Save the workspace. We can now run the batch. Click Run on the batch and name as batch_sensitivity. Set the run type to live. Press OK. Here is the screenshot of the progress log. You will see a single generation and compilation stage and two different execution stages. Company Base and Company Sir Inc. This is the results workspace. Open the aggregated results. Select the realistic layer. Go to the Aggregated tab. On row 11, you will see that for these aggregated results, the model string, which is the assumption file name, refers to the base assumption file. For details about the placeholder variable, you can refer to the examples of placeholders in the help file. This completes the batch sensitivity run. Section 3.2. For this section, we will set up a batch to run the same model using different stress names, which are used when reading values from the assumption tables. We will continue using the Stage 3 workspace. Now we will show how to apply stresses using model string and batches. For reference, this is the same way it is done in our Solvency II standard code models. The objective is to run the same model 3 times using a different value for the variable int rate each time. These are base scenario, increase of 20%, and decrease of 20%. We'll first look at the assumption file. Open the file ext assumptions int rate stresses in the assumption folder. Observe there is a new table with the range name int rate stress table instead of the table int rate. This table contains a different value for the interest rate assumption depending on the stress name, i.e. base, up, and down. This is the file we will use. Close the file. Now make a copy of the assumption set Realistic Assumptions ext. Under Component, select Duplicate and name as Realistic _Assumptions ext _stress. Open it. Use the Assumptions Connection String property in the assumption set to locate the ext assumptions int rate stresses file. Repeat what we have done previously. Right-click, select Locate OLEDB Connection String, and follow the steps. Go to the Variables tab. Add the variable int_rate_stress_table. The aggregates property is set to no, and the portfolio property is set to no. In the assumption table property, right-click in the formula pane, select Locate Table, select int rate stress table. Next is the formula property. Right-click and select Specify External Assumptions. It's a one-dimensional array. The dimension name is stress. And the data type is character. Press the check button to confirm that the values are read correctly. These are the stress indices: base, up, and down. Click OK twice, and the formula property will be set to external and stress. This variable will be used to hold the values from the new interest rate stress table. To indicate which index we are referring to, the next variable to add is stress_name. The data type is character. The aggregates property is set to no, and the portfolio property is set to no. The formula is set to model string 2. This variable is used as an index to access the values from the interest rate stress table and uses model string 2 in its formula to allow us to override it using the batch, so it can be base, up, or down. Next, amend the formula for int rate so it will read the value of the interest rate depending on the stress name from the interest rate stress table. The formula is as follows. Delete the value in the assumption table property for this variable. This completes the assumption set setup. Essentially, when we run the batch, model string 2 will tell the model which stress name it is referring to and use the corresponding interest rate for the calculation. We will create a new model for stress run purposes using the assumption set we just created. Make a copy of the model Company Ext. Under Component, select Duplicate and name as company_stress. Open it. Double-click on the realistic layer. Change both liability programs to use the Realistic Assumptions Ext Stress assumption set. This completes the model setup. Next, create a new batch. Right-click on Batches and add batch. Name as batch_stresses. The first model alias is company base. The second is company int down. And the third is company int up. The model property is set to company stress. For the model string override, the assumption file we will use is ext_assumptions_int rate stresses. We can copy the name of the file from the assumption folder. All model aliases are using the same assumption file. The difference is model string 2 override. Recall that in the assumption set, we created a new variable, stress name, and the formula was set to model string 2. So for the company base model alias, model string 2 override is set to base. For company int down, it is down. And for company int up, it is up. Set the runtime parameter for this batch to runtime parameters. This completes the setup for our batch model. Save the workspace. Note that we could now run the batch with different stress names. However, to run the model standalone, we will need to give a value in the model string 2 property in the company stress model. Otherwise, it will cause an error when running the model. Open the company stress model. Go to the model properties. We could add base to model string 2. Or we can define runtime parameter set variables to add more flexibility at runtime. Let's add a new runtime parameter variable. Open the runtime parameter set, Runtime Parameters. Go to the Variables tab. Add the variable name, stress_name_RTP. The data type is character. The display name is name of stress to run for S2 models. The display instruction is Enter stress name to run, not required for batch runs. And the default value is base. Now we can go back to the properties of the company stress model and set model string 2 to the following. And save the workspace. Let's run the company stress model first. Click Run. Name as company_stress. Set the run type to live and open the runtime parameter set variables. The assumption file is extAssumptions int rate stresses. We can copy the name of the file from the assumption folder. Press OK twice. The model will run with no errors. Let's now run the batch. Click on Batch Stresses and run the batch. Name as batch_stresses. Set the run type to sample all. This time we don't need to amend the runtime parameter set variable as we have used model string override and model string 2 override in the batch. Press OK. Once your model has finished running, go to the Analyzer tab. The model name we are looking at first is Company Base. Click Confirm Layer Selection. Choose the NP-end program. Select the variable int rate. The interest rate is 0.05. Let's change the model name to Company Int Down. Click Confirm Layer Selection. Choose NP-end. Select the variable int rate. You will see this time the interest rate is 0.04. This is how you can use a batch to run the same model using different stress names. This concludes the External Assumptions, Placeholders and Batches module.